So in this video, we are going to solve problems from exercise 8.4 and we are looking at problem number 5 where we prove the following identities where the angles involved are acute angles for which the expressions are defined. So we have already seen the first 5 problems and now we are going towards the 6th and 7th problem in this video. So let's zoom in. Now these problems are of the type left hand side equal to right hand side. So an equation is given to us and we have trigonometric ratios on left hand side and we have trigonometric ratios on the right hand side, and we have to simply prove left hand side is equal to right hand side. That is the format. And typically what we are doing in all these problems is we take the left hand side expression and we convert all the trigonometric ratios into the two basic trigonometric ratios, which are sine and cos. Convert everything into sine and cos and then try to derive the expression which is given on the right hand side. That is the typical strategy that we are trying to apply for all the problems in this question. Now let's focus on this, which is problem number 6. Okay, so left hand side is under root of 1 plus sine a the whole divided by 1 minus sine a, and right hand side is sec a plus tan of a. So typically when we have an expression with an under root, we rationalize the denominator. Okay, so let me write the left hand side now. So left hand side is equal to under root of 1 plus sine a the whole upon 1 minus sine a. This is my left hand side. Now let's try to rationalize the denominator, which means, so first let me note it down. Rationalize. Let me try to zoom in. Rationalize the denominator. Okay, and we are going to rationalize the denominator inside the under root sign. So I'm going to square root of. Okay, so this is the original expression inside the under root sign 1 plus sine a 1 minus sine a. Okay, and multiplied by, so denominator we have to rationalize, so 1 plus sine a will be at the denominator here, and again I will multiply by 1 plus sine a itself. Okay, and these are okay, and this is the denominator. So both note that this entire new expression which we are using to rationalize the denominator is under the under root sign itself. Okay, now let's continue here. So that will be equal to square root of, I will keep the square root as it is. So on the numerator I am going to get 1 plus sine a the whole square, and my denominator is going to be, so denominator is of the form a minus b into a plus b. Okay, where this is a, okay, and this is my b. So that is equal to a square minus b square. Okay, so my denominator is now going to change to a square, which is 1, minus b square, which is sine square a. Okay, and now let's further continue. So under root remains as it is. So 1 plus sine a is the whole square. I'm going to keep it as it is, divided by, what is 1 square minus sine square a? That is equal to cos square a. Okay, that is from our standard here. I'm just going to make a note of that, because we have sine square a plus cos square a as equal to 1. Okay, so if I take this sine square a on the right hand side, this is going to be 1 minus sine square a. So that will be equal to cos square a. Okay, so thus we have a square term on the numerator and a square term in the denominator. So now this square root can be removed. So that is going to be equal to 1 plus sine a the whole divided by cos of a. And now that can be written as 1 upon cos a plus sine a upon cos a. And that is equal to, what is 1 upon cos a? That is equal to sec a, and sine a plus cos a is equal to tan of a. And this is exactly what is on the right hand side of the equation. Let's go back to our question. So yes, we started with LHS left hand side and we derived right hand side, which is sec a plus tan a. Here it is sec a plus tan a. So this is how we solve these questions. Now before we go to the next question, let's erase this. Okay, now let's focus on question number 7. So let's first read the question. Left hand side is the expression sine theta minus 2 sine cube theta the whole divided by 2 cos cube theta minus cos of theta, and that is equal to tan of theta. So just one simple expression, one simple trigonometric ratio on our right hand side is tan of theta. Now we are going to follow the same approach. We start with our left hand side of the equation. Okay, that is equal to sin theta minus 2 sin cube theta, the whole divided by 2 cos cube theta minus cos of theta. Now very clearly sin theta is common in the denominator, so I am going to take it out of the bracket. So that's going to be 1 minus 2, yes, 1 minus 2 sin square theta, okay, and this whole divided by, once again cos theta is common from the denominator, so it's going to be 2 cos square theta minus 1, okay. Now here we can clearly see that this sin theta upon cos theta is equal to tan theta, which is what the right hand side is. So whenever you are in the middle of solving the left hand side, we are trying to simplify the left hand side expression. Keep a watch on the right hand side of the equation, what we are expecting. So once we get some expecting term in the middle of our simplification, we know that this thing should be equal to 1, because I have already got tan of theta. So tan of theta into this whole expression should be equal to 1. So now that is our focus. So I'm going to first write here this is tan of theta, and into this bracket is as it is. So okay, let me write here 1 minus 2 sin square theta, the whole divided by, this is 2 cos square theta minus 1. Okay, so once again, just to emphasize the point, tan theta is already there on right hand side, and I'm trying to simplify the left hand side, and I've already got tan of theta. So very clearly this whole expression should be equal to 1. Now let's see how that can be converted into 1. Now in this expression, so I'm just going to continue, that is equal to, so this I'm going to write as it is, tan of theta into, now this 2 sin square theta can be split into sin square theta and sin square theta. This is how it will look. So 1 minus, I can write this as minus sin square theta minus sin square theta. Okay. Note that this is minus 2. So this is going to be minus sin square theta minus sin square theta. Okay. And I'm going to do the same thing with the 2 cos square theta. I'm just going to split it as cos square theta plus cos square theta minus 1. Okay. Just splitting up the 2 sin square theta into sin square theta, 2 cos square theta into cos square theta, cos square theta. Okay, now let's focus on this. What is 1 minus sin square theta? 1 minus sin square theta is cos square theta. And what is cos square theta? Okay, and what is cos square theta minus 1? That is equal to minus sin square theta. Okay, let's write it down, that way it will be more obvious. So we have sin square theta plus cos square theta is equal to 1. Okay, so 1 minus sin square theta will be equal to cos square theta. So therefore, so there are two things that we can derive from this equation. Okay, one is, okay, so one is okay, cos square theta will be equal to 1 minus sin square theta. Okay, so that is our I'm just going to mark it like this with the same orange color. So that is what we want here, 1 minus sin square theta, 1 minus sin square theta. And this is first thing. And second thing is cos square theta minus 1. So yes, so that is going to be, if I bring cos square theta and minus 1 to the left hand side, on the right hand side I get minus sin square theta. And that is exactly what is the thing we have marked in the blue. Okay, so I'm going to substitute these values, okay, in this equation. So okay, fine. So let's continue. So that is equal to, okay, so tan theta is as it is, okay, multiplied by, what is 1 minus sin square theta? It is cos square theta minus sin square theta, and that is our numerator, and in the denominator we get cos square theta minus sin square theta. And as you can clearly see, numerator is same, denominator is same, they will just cancel each other out. So I'm going to just cancel them each other out. Okay, cancel, that's going to be equal to 1. and thus this left hand side is now equal to tan theta, which is equal to our RHS. Okay, so we started with this LHS, what was given to us, and we got our RHS, which is tan of theta. Thus this is also done. Okay, so let's erase this. Cool. And now let's go to our question number 8. So let's take this down. This is question number 8. Okay, let's read the question. So sine A plus cosec A the whole square. Let's zoom in. Okay, yeah, plus cos of A plus sec of A the whole square, that is equal to 7 plus tan square A plus cot square A. Okay, so this looks quite straightforward because this is the square term, this is the square term. We are going to use A plus B the whole square. We'll get sine square A here, we'll get cos square A, that will be equal to 1. And then let's see how we can simplify further. But again, the general strategy is try to convert all the trigonometric ratios into sine and cos, and then try to convert and then try to express them in the right hand side. Sorry, try to express them in the right hand side expression, whatever comes in the right hand side. But first we start with getting them to into a basic trigonometric ratio, which is sine and cos. So yes, first let's note down our left hand side. So left hand side is equal to sine A plus cosec A the whole square, and I'm going to write here plus cos A plus sec of A, okay, the whole square. Now we are going to use, I'm just going to make a note here, we are going to use A plus B the whole square, this identity, which is equal to A square plus 2AB plus B square. Okay, so let's do it. Yes, so that is equal to, this is going to be sine square A plus 2 sine A cosec A, okay, plus cosec square A, okay, and plus this is going to be cos square A plus 2 cos A sec A plus sec square A. Okay, so just to understand this, we have expanded here, okay, and this term we have expanded here. Okay, now very clearly we can see that sine square A plus cos square A, that is going to be equal to 1. So let's first make a note of that. That is equal to 1 plus, now if you look at this term, sine A into cosec A, that is equal to 1, because sine A is reciprocal of cosec of A. Same goes with cos A and sec A, they are reciprocal of each other, so their product is going to be equal to 1. So that is going to be equal to 2 plus, and this is our cosec square A. Now I need one more highlighter. Okay, and then we have cosec square A and sec square A, that we will write as it is. So 2 plus 2 plus cosec square A plus sec square A. Okay, let me just make it clear. So this is our green thing, and okay, I didn't use a different highlighter, but fine. This is that 2 and 2. Okay, this sine A cosec A cancel each other, cos A sec A cancel each other because they are reciprocals of each other. Okay, so now we are at this position, and let's 1 plus 2 plus 2, that is equal to 5 plus cosec square A, okay, plus sec square A. Now at this point we have a look at our right hand side. Let's zoom out. Yes, so our right hand side of the equation is 7 plus tan square A plus cot square A. So we want tan square A and cot square A in this left hand side expression. So we know how to get it because that is also another identity. Now this will be equal to 5 plus, what is 1 plus tan square A? That is equal to cosec square A. So I am going to write here 1 plus tan square A, that is equal to cosec square A, and same we have 1 plus cot square A, that is equal to sec square A, again from standard trigonometric identities. And once again we have here, okay, we have this 5, 1 and 1, they are going to add to each other. Let me not strike them out. 1 and 1. So they're going to add to each other. That is going to be equal to 7 plus tan square a as it is and cot square a as it is. This is the exact expression what is expected as our right hand side. And thus we solve this problem. We started with this LHS. Oops. We started with this LHS and we just expanded them using this standard standard identity a plus b the whole square. And that's how you solve this problem.